Welcome. Welcome to programming part of two-dimensional arrays. Programming part of two-dimensional arrays or matrices. Let us create a new file. So after that, the usual skeleton include stdio.h, main. Now let us declare a two-dimensional array or matrix. What is it? It has two dimensions. So the format is integer ESA, and you have to specify two dimensions. This is how you specify. So in the case of single dimensional array, there will be only one dimension. In the case of two-dimensional array, there will be two dimensions. These 5 represent the number of rows, these 5 represent the number of columns. This need not be same. It can be 5 by 3, 3 by 5, it can be anything. So it can be anything. Okay, 5 by 5 matrix. 5 by 5 matrix. Maximum size, remember again, here it is row maximum size, here it is column maximum size. Row maximum size, column maximum size. So that means maximum number of rows is 5, maximum number of columns is 5. So declared it. Let us try to actually just a minute. Okay, let us try to read the elements and print the elements of the matrix. How to do it? So in the case of matrix, you have what is called as order of the matrix. Let it be mn. M represents the actual number of rows, n represents actual number of columns. So 5 and 5, they represent the maximum number of rows, maximum number of columns, whereas mn represents the actual number of rows, actual number of columns respectively. Okay, now let us read the order of the matrix. Enter the number of rows and columns. So scanf %d the undium undian. So number of rows and columns. Okay, let us save it. Let us save the program. Save, say ex8 ex8.c, say ex8.c ex8.c. Let us save it. Okay, now read the elements of the matrix. Remember, if you want to read the elements of a single dimensional matrix, you require one loop. If you want to read matrix or the elements of a two-dimensional matrix, you require two loops. That too, one loop is inside another. That means you require a nested loop. I repeat again, if you want to read two-dimensional matrix, you require two loops, one loop nested in another. So you require nested loop to read the elements of the two-dimensional array or matrix. So for say I equal to 0, I less than m plus plus of I. So the nested loop is for j equal to 0, j less than n plus plus of j. Okay. So what you are going to do, you are going to read the matrix elements. What is the matrix element? What is the matrix element? Here A is the matrix, so A of, so you have to use ampersand also, A of I, A of I j, A of ij. So what we are doing here, so we are reading the elements of the matrix. So first I will be 0, then we'll go into this loop, j will be 0. Okay, so first 0 0th element is read. Next what happens is, this will be incremented. So for every row all the columns, for every row all the columns, next row all the columns, next row all the columns. That's how it works. So 0 0 0 1 like that, 0 0 0 1 up to 0 m minus 1. Next 1 0 1 1 up to 1 m minus 1. So like that it will go. So printf, enter the elements of the matrix. Enter the elements of the matrix. Enter the elements of the matrix. So you have read the elements. Now print them. Now print them. Copy it and paste it. Copy it, paste it. You can press Ctrl V. So printf, the elements of the matrix, the elements of the matrix are, so again for I equal to 0, I less than m, I plus plus of I, j equal to 0, j less than m plus plus of j. Instead of scanf, you write printf, and in printf ampersand is not required. Ampersand is not required. So separate the elements by space. Separate the elements by space. There is one another thing you have to do, but before that let me build it and execute. Let me build it. Compilation failed. There is some problem. What is that problem? I undeclared, j undeclared. So you have to declare them. So here itself we can declare. So fine. Execute. Number of rows, number of columns. Let us take 2 by 2 matrix. Enter the elements of the matrix. So 1, 2, 3, 4. Let the elements of the matrix be 1, 2, 3, 4. You can see the elements of the matrix are 1, 2, 3, 4. 1, 2, 3, 4. So it is correctly printed. But okay, here you can see the elements are not printed in the form of matrix. Okay, they are printed in sequence. You know, it is correct, it's not wrong. But if you want to print it in the form of the matrix, what you can do here is, so this statement is inside this one, inside this for loop. So after execution of this for loop completely, so what you can do is you can print the new line. So that means what you can do here is, printf /n. So like this. Let us build it. Let us execute it. Again say 3 by 3 matrix. 3 by 3 matrix. 11, 22, 33, 33, say 44, 55, 66, 77, 88, 99. So here you can see the elements of the matrix are printed in the form of the matrix. It appears similar to the matrix. It appears similar to the matrix. So what we are doing here, so if you observe carefully, this printf statement is part of this loop. That means j goes from 0 to n, and this will be repeatedly executed. When j value becomes n, because it is j less than n, when j value becomes n, it will come out of this printf statement. It will go to the next statement. What is the next statement? Printf slash n. That means for all the columns you execute it. After printing all the columns, print a new line, and then it goes here and I value will be incremented. That means it goes to the next row. It goes to the next row. So this is a simple program. This is a simple program in which we have read the elements of the matrix or two-dimensional array and printed the elements of the matrix or two-dimensional array. Now let us change it. Let us change it. Let us change this program. Let us change this program. If you want, you can take a snapshot of it. Pause the video and take the snapshot of the video. Okay, now what we are going to do is we are going to add two matrices. Add two matrices. So what we have to do? So we have one matrix A55. Let us have another matrix B5. B55 say. This is another matrix. So definitely because you are performing addition of the matrix, you should have another matrix where you store the result of the addition. Let us call it as C55. Let us call it as C55. So we have three matrices. The matrices to be added A, B, and the matrix in which you store the sum of the matrices, that is C. Now m by n is the order of the first matrix. Let us call P by Q as the order of the second matrix. PQ as the order of the second matrix. So A is of m by n, B is of P by Q. P by Q. Okay. So you have read the number of rows and columns of first matrix actually. Of first matrix. Okay. Now what we can do? We can read the number of rows and columns of the second matrix. I am just copying it. What I am going to change, enter the number of rows and columns of second matrix. Now what do I have to read? I have to read PQ, not M N, PQ. So the order of the first matrix is m by n, the order of second matrix is PQ. Now after that you can read the elements of the matrix and then perform the addition and then print the sum. But before going to do the matrix addition, we have to check one thing. We have to find whether matrix addition is possible or not. Whether matrix addition is possible or not. When the matrix addition is possible, if the number of rows in first matrix is equal to the number of rows in the second matrix, If the number of columns in the first matrix is equal to the number of columns in the second matrix, then only matrix addition is possible. So we are going to check. So what we are going to check, if M equal to P, M equal to P, we can check whether they are equal or not, whether they are equal or they are not, whether they are not equal. So we can do both the things, but the remaining statements are to be executed only if both are same. We will do like this. If M equal to P and remember we are writing something different from what we discussed in the theory. Okay, that means if M equal to M and N equal to Q, then what does it mean? Is matrix addition possible or not? So matrix addition is possible. Matrix addition is possible. Then you can go and do all these things. Then you can go and do all these things. Okay. If matrix addition is not possible, then what you can do? Printf the matrix addition is not possible. Matrix addition is not possible. So print it and then return, or otherwise you can just print it because the return is there at the end, already it is there. Okay, it will not immediately come out. So anyhow, the next statement that will be executed is this one. Let us try to compile it. So whenever you are writing a big program, so repeatedly save your program, it seems it is automatically saved, that's why it is disabled. Okay, so you periodically save the program and also compile the program. After adding few statements, you save and compile. So do the programs in an incremental fashion. But let us execute it. And let us take the case where the matrix addition is not possible. Enter the number of rows and columns of first matrix. Let us say it is 2 by 2. Enter the number of rows and columns of second matrix. Let us call it as 3 by 3. What does it mean? Is matrix addition possible? So matrix addition is not possible. Matrix addition is not possible. Now if the matrix addition is possible, this is the case. If the matrix addition is possible, we are reading the elements of the matrix, enter the elements of the first matrix. So it is a little bit a bigger program. But be careful, enter the elements of the first matrix. Let us copy it. Copy the same code. Printf, enter the elements of the second matrix. So it is P, Q, and the matrix is B. Okay, you have read it. And you have read the elements of the first matrix, the elements of the second matrix. Now we have to perform the addition of the matrices. Addition of the matrices. In that case, again you require a nested loop for I equal to 0. Here because M by N is same as P by Q, So you can use so like this, j equal to 0, j less than n plus plus of j. So like this. So you are using m by n, but m by n is same as p by q. So instead of mn, you can use p by pq respectively. So I think this is 0, not O. Okay. What you have to do? C of I j is equal to A of I j plus B of I j. So this is what you have to do. You have added. Now the elements of the matrix or the elements of the matrix after matrix addition. After matrix addition are, what are the elements of the matrix? Where are the elements of the matrix after addition? They are in C. So you have to actually use the same loops, but you have to print C. You have to print C. Okay. So this is what you have to do. So save it, build it, fine, fantastic. So let us take both the matrices of 2 by 2. 2 by 2. Elements of the matrix be 1, 2, 3, 4. Okay. Elements of the second matrix be say 5, 6, 7, 8. So the sum, the elements of the matrix after matrix addition, you can see 1 plus 5, 6, 2 plus 6, that is 8, 3 plus 7, that is 10, 4 plus 8, that is 12. So we are getting correct result. We are getting correct result. So this is matrix addition example. This is matrix addition example. Matrix addition example. So now try to do matrix multiplication on your own. Try to do matrix multiplication on your own. Matrix multiplication means, so one hint is reading and printing, they are same, but while multiplying, so what you have to do, check what you will be doing mathematically. So you will be multiplying the first row with the first column, then you will get one element. First row with second column, then you will get one element, like that. So you require 3 loops. You require 3 loops. Okay. You will have 3 loops. There will be one more loop here. There will be one more loop here. And what is that loop? That loops goes from 0 to the number of columns in the first matrix or number of rows in the second matrix. Number of columns in the first matrix or number of rows in the second matrix. But remember, both are same. Why? When matrix multiplication is possible? When matrix multiplication is possible? When the number of columns in the first matrix is equal to number of rows in the second matrix. So that's why that loop goes from 0 to number of columns in the first matrix or number of rows in the second matrix. And what you have to add, Cij equal to Cij plus what you have to add, actually it will be aik plus bkj, provided that index variable is k. That means if for k equal to 0 to k less than say n plus of j, because they have to match, plus of k equal to 0, k less than n plus of k, Cij equal to Cij plus aik star bkj, aik star bkj, that you have to do. If it is little confusing, initially you can remember, but do matrix multiplication manually, then you will come to understand it, how that loop actually works. So do it. Best of luck.